Hi, Mike and Tony here, and we're back for another exciting episode of the Robot Whisperers. In our last episode, it was all about arc welding, things like gantries, part positioners, and weld paths.
We showed you how you could combine a virtual robot with a part positioner and a gantry to create a 9-axis device.
And how your robots can perform like a symphony of motion. So if you're having relationship issues with your robots and you can't get them to perform the thousands of welds they do every day,
well, just sit back and relax because Episode 3, Robotology of Spot Welding, is coming up next.
Hi, I'm Mike and this is Tony, and we're back for another episode of the Robot Whisperers. On today's show, we're going to demonstrate how to simulate a robotic spot welding application using 3D software.
If you drive a car, you're surrounded by spot welds that are made by a robot like this one, and spot welds are what hold the car together.
And obviously, if those spot welds aren't strong and perfectly placed, it can create all kinds of issues.
That's right. We're going to show you how easy it is to use 3D simulation software to place your robots so that they can reach all the weld points and not collide with any of the sheet metal or the tooling in the work cell.
When talking about something like a car body, which has spot welds in hundreds of places, preventing a collision is absolutely crucial, just like when you're driving on the road. And using 3D simulation software, we can prevent this from ever happening.
The goal is to achieve the welds on the car and best utilize the robots in the work cell for optimum performance, flexibility, and efficiency.
And this significantly reduces your time to market because you can plan for your robotics before you ever invest in hardware or labor. This spot welder is an amazing example of mechanical technology that's supported by a sophisticated software program. What it's capable of simply defies the laws of physics and everything Einstein ever taught us.
Well put, Mike. This robot's rated at loads of up to 300 pounds. It can move at speeds of up to 6 feet per second and stop virtually at the same point in space each time.
And it can create those perfect welds at the same point over and over again. Robotic spot welding is a complex process. There's a lot of things happening all at once. I mean, there's processes grouped inside of other processes.
It's kind of like the solar system. With all the planets rotating on their axes, rotating around the sun, with our solar system rotating around the galaxy and all the moons orbiting around the planets, I mean, if one thing gets out of rhythm, it could throw the whole thing out of whack. I mean, when worlds collide, watch out.
Okay, Captain Kirk. That is a great example of how robots work together. There's a lot of components involved here. There's the weld gun itself, which is controlled by this servo motor here. There's a weld controller behind us that controls the welding process. There's the robot itself with all its parts, as well as there's tools and fixtures and clamps throughout the work cell. As Tony said, there's a lot going on here.
You know, we talk a lot about automotive spot welding, but spot welds are found in a lot of different products that you use every day, from furniture to appliances.
And 3D simulation is applicable at companies of all sizes, whether you're a large OEM or a small supplier or tool integrator. With car bodies, there are thousands of spot welds that need to be processed on the assembly line.
Most welds are assigned to a robot, but not all of them. The weld gun on the robot must access and process the weld, accounting for things like robot payload, gun squeeze pressure, weld time, and the required electrical current. Every weld gun has different parameters. It's pretty easy to understand, right? Thing is that you have to find the right gun for the job, and that's where 3D robotic software is a huge advantage.
We all know the frustration of looking for the right tool for the job. And just like Murphy's Law, when we try to find it, it's never there.
And you know, it's the exact same thing with engineers. I mean, can you imagine trying to use the real weld gun to try to figure out which one's right for the job?
And if there's hundreds of weld guns to choose from like this one in your database, it's virtually impossible.
Companies are using simulation software to assign thousands of spot welds to the hundreds of robots that they have in production. That's because they can simulate the weld guns on each of the welds automatically. Automotive companies maintain a 3D inventory of weld guns and a library and use software simulation tools to search for all the weld gun solutions that will satisfy any weld or group of welds on the car.
Automotive companies and their suppliers for years have worked to standardize their manufacturing equipment and weld guns like this one to help minimize cost. And with simulation software, they can minimize the number of weld guns they use for many different applications.
This process can be accomplished on many welds very quickly, and it's very accurate. It can check each weld gun for any collisions at any rotational interval. It can also check with the gun in a flip condition, which is just basically welding upside down. And you know, there are certain other parameters that the robot needs to consider when it calculates motion, like its tool point location. When a weld gun's mounted to the robot, the operator wants the robot to calculate motion according to where the weld tips are located on the gun. Once the engineer provides this information, the software automatically inputs it into the robot's controller in the simulation. This allows the robot motion to consider the tool point location when calculating different motion types, like linear or circular. This function also can be used in fixed tool point locations, like with pedestal welding. The engineer can examine the welds and the weld guns being applied. They can visualize the direction of the weld gun on the weld spot to determine ingress and egress to and from the weld spots.
You know, there are several benefits here. First, the robot programmer can plan for the robot paths to optimize the cycle time. It also helps with the longevity of the robots. Not to mention that you can do what-if scenarios until the cows come home.
And on Anna Irene's farm, that would be in about, 4 hours from now.
I got to tell you, Tony, this robot thinks that's utterly ridiculous. You can create the what-if scenarios with just a couple of clicks of the mouse. That's certainly better than dragging a bunch of robots around like this one on the shop floor to physically test the different programs necessary for production.
That's a nice segue into our next topic, robot placement. Robot placement is one of the more difficult tasks in manufacturing.
And that's because each robot can have multiple tasks assigned to it, along with welding sheet metal parts.
And since industrial robots are inherently flexible, the number of tasks that can be assigned to them is virtually limitless.
Robots that have a gripper attached to the weld gun can handle materials leaving and entering the system.
The robot could have a tool changer that switches the different tools that the robot uses in production.
The robot can also have a part pickup, a part drop-off. It can have a weld gun that needs to reach multiple weld points, as well as a tip dresser to keep the weld points fresh, and it can have 3 or more products that it has to produce.
With 3D simulation, the engineer can view all the workable robot placement solutions for any given area. That can really reduce the number and scope of changes throughout the design process.
The 3D animation defines the area to place the robot in the work cell along the X, Y, and Z axis.
The engineer defines which task or tasks to be considered for the robot's placement. Then the system calculates all the possible robot placement locations inside of the user-defined area. This makes it easy for the user to identify both valid robot placements and also unbuildable conditions.
This kind of virtual validation can minimize costly rework later on, and any errors corrected now is certainly less significant in cost later on during the build phase.
And here's why. If a robot needs to reach 2 pickup locations and 2 drop-off locations, as well as 14 weld spots, the 3D software analyzes and calculates a best solution for robot placement.
It's how we can ensure virtual prove-out of the production system prior to building it. Think of the peace of mind that can provide.
You discover now, rather than later, if all or part of the robot paths or paths are reachable. And the robot software will display which locations the robot cannot reach. Robot reachability is important because a robot can have all different types of tasks. Since robot processes are constantly being modified in the design phase, there's a lot of juggling of equipment in spot weld locations.
Weld spots also tend to get traded from robot to robot, so it is important to be able to check all the robot locations for reachability quickly and easily.
Simulation enables the engineer to select each robot task and calculate whether the locations in each path are reachable. The software tells the user if points are reachable, out of joint limits, or not reachable.
Many automotive companies and line builders need to communicate design intent. That is, they need to show the weld gun accessibility to any given weld. Using simulation, the engineer can easily create 2D representations of each weld, showing how the weld gun accesses it. These cut sections can be stored as 2D drawings for later reference.
Auto body assembly line processes are fluid and they change from day to day. Some changes can be minor, like adding a weld spot to a robot. Other changes can be significant and they can affect every robot in the work cell. For example, what if a robot needs to be moved forward or up? You would want to see how this would affect any given weld. What if you processed the welding of 4 robots and then found out the entire tool fixture moved? Simulation gives you the ability to see the effect on the robot or all the robots when a change like tool placement occurs.
Let's face it, many simulation engineers have a robotics background.
And it just goes without saying that when you're programming a robot, whether it's real or it's virtual, it makes sense to have knowledge of robotic processes.
For example, some robot programmers prefer to have a robot teach pendant interface when they simulate. Teach pendants show each line of robot code in the program as the robot executes it.
And the simulation can operate the same way. When the NRL teach page is used, the engineer can see the robot code as it's being executed in the simulation.
And that's another big benefit to 3D simulation.
We've covered a lot of ground here, so it might be a good idea to review some of the benefits that 3D simulation gives companies who do robot spot welding.
Well, one of the benefits is if you can standardize components, you can minimize the equipment they use during operation. Plus, if you can identify production errors before the production phase, you can reduce downtime and rework when you go operational.
And that's a definite money saver.
Plus, you can leverage your existing CAD design by incorporating it into the manufacturing simulation.
All these benefits help you save time and money and keep pace with your competitors, especially in the automotive industry, where a car can go from concept to production in less than a year.
Well, that's it for this episode of the Robot Whisperers. But be sure to join us next time when we share a few of our secrets on some of the advanced capabilities of robot simulation, as well as talk about what's new in simulation technology.
So, stay tuned, and we'll see you there.